Hello everyone, welcome to session 5 of LTEC 654, Programming Games and Simulations. This week we're going to jump right in to working with Godot. So let's talk about the key concepts we've learned about related to buttons. We've learned that buttons are a type of node, and in fact if you look on the right hand side here, you'll see that there are lots of different kinds of buttons that we can use in our projects. We just used a regular old button, but there are checkbox buttons, check buttons, color picker buttons, menu buttons, option buttons, tool buttons, so on and so forth. We also learned that buttons don't do anything by default. They need to be programmed in order to actually provide some functionality to our projects. We also learned that buttons send signals. And we also learned that signals alert our programs that some kind of event has occurred, such as a user has pressed a button or clicked a checkbox. Now, what happens when a button is pressed or a checkbox is clicked requires code placed in a function. And it is our job as the programmers to write that functionality so that the interface or the game responds when the user does something with a button or a checkbox. Now, a couple of important things I want to highlight. How do we tell whether or not a button has a signal attached to it? Well, helpfully in the scene tree, anytime there's a control such as a button, if there is a signal attached to that button, we see this symbol, which I've circled over here on the right. And that simply indicates that there is a signal associated with that button. Now, if we were to click that little signal icon, the node panel would open up, and we can see that yes, the signal that is attached to the button is actually a pressed signal. In other words, when the user presses a button, a signal is dispersed to the program. And if we right click on that, we could edit this, or we could actually disconnect that signal from that particular button. Now, another important concept that we've started learning about is known as conditionals. Now, conditionals allow programs to perform different actions depending on whether a condition is true or false. So let's take a look at some examples. Now, the basic example is a simple if-else statement. So here's a little snippet of code. If you look at line 8, we say if x is equal to y, then do something. If that is not true, then we want you to do something else. And you can see we have two print statements there in line 9 and line 11. Now, I'm sure you're asking yourself, why two equal signs? Well, in programming, one equal sign is assignment. For example, we might want the variable x to be assigned the value 5. In other words, we're making x equal to 5. That's an example of assignment. However, in if-else statements and other conditionals, we want to do a comparison. And so two equal signs indicates to the program that we need to do a comparison. In other words, is x the same as y? So this is an important concept that applies across lots of programming languages. And just like Python and Godot script, there's a difference between assignment and comparison. So two equal signs is the equivalent of asking, are these two variables the same? And if they're true, then do one thing. If they're not, do something else. What if we need to check more than one condition? Well, we can do that in Godot by using something called an elif or an else if. So take a look at line 7. It says, if x equals 5, do one thing. Elif, line 9, x equals 10, then do something else. And if neither of those are true, then we have the end else condition, which says do something else. And we can use as many elif statements as we want in our if-else statement. Another thing we can do with conditionals is check for non-equivalence. So take a look at line 8 here. If x is not equal to y, then do something, else do something else. How do we specify non-equivalence? It's the exclamation point equals. That is the not equals operator. Here's another example where we want to check if multiple conditions are true. Take a look at line 8. If x equals 5 and y equals 5, then do something. So we use the AND operator, the keyword AND, A-N-D, to check if both x is equal to 5 and y. That's the AND operator. We also have an OR operator. If x is equal to 5 or y is equal to 10, then do something else, do something else. So that's a quick review of conditionals. And as you will find as we begin to work on our games and simulations, conditionals are really essential to programming logic. Now, let's talk a little bit about programming assignment 3. This assignment, of course, was all about making sure you understand the concept of a scene tree. And let's take a look at this very simple mock-up that I've made of assignment 3. So you could see here that body has no children on the left, and on right we don't see any of the pattern scene. However, when I add the first child to body, we see that a scene gets added on the right-hand side. And importantly, even though body has one child, because computers start counting at 0, the index of that first child is actually 0. Now, if I add a second child, we see another pattern show up in the viewport. And even though there are 2 children, the index of the last child added is 1. Very important concept. And of course, when I add a third child, body now has 3 children, but the index of the last child added is 2, not 3. So the question becomes, of course, for this assignment is, how do I remove the last node added to the tree? And in this case, the last node has an index of 2. Now, I could write the following code. I could say variable named pattern. I want that to be equal to body get child of index 2. And then I could remove that child stored in the variable pattern. Now, this would actually work. And this is an example of hard coding index 2 into my program. Now, there's a problem with this, though. The first time I click remove from the top, it will work. However, if I click remove from the top again, it won't work because now there are only 2 children at index 0 and 1, and there's no child at index 2. And so the program will break and I will get an error. And so this is actually a bad example. And it's a bad example because the hard-coded index 2 is not reusable. So a better solution is to make our code scalable. And the way we did that in last week's tutorial and in this assignment is we create a variable called number of patterns, and we get a count of the number of children. In this case, there are 3 children. And then in pattern, we say get the child that is 3 minus 1. In other words, get the child at index 2 and remove that child. Now, the reason this is valuable is because it will also work again. Even if there are only 2 children, I can say get the number of children, 2. 2 minus 1 is 1, and I can remove the child at index 1. And so this code is dynamic and will adjust based on the number of children that body has. This is better code. Now, of course, we also had the issue of how do I remove the first node added to the tree? In other words, the node at index 0. And many of you figured this out on your own, but some of you had to ask. And here is the code that solves this issue. The variable pattern is equal to the child at index 0, and then I can remove this child. Now, interestingly, this is not considered hard coding because every time you remove a child, the rest of the children slide down the tree. And so as long as body has children, even though you're removing the child at position 0, the one that was at position 1 slides down to position 0. And so this is very reusable code. So you might be asking yourself, where are we going with all of this? Now, remember at the beginning of the semester, I argued that this course is really about 3 overlapping areas: computer programming, game design, and learning design. Now, in the first half of the semester, we are focusing solely on computer programming. And sessions 1 through 8 are all going to be dedicated to understanding Godot and, more importantly, Godot script. Our goal is to be able to build up our foundational programming skills so that in the second half of the semester, sessions 9 through 16, we can focus on designing and developing our own original games and simulations. But we can't do that in Godot unless we have that foundational programming knowledge necessary to develop basic games and simulations. So that's where we're going. So we have about 4 more weeks where we're really going to be focusing on computer programming. Now, let's connect some of what we've learned to a real-world game. And let's do that by answering this question. How do the programming concepts we've learned so far relate to a real-world game like PacMan? Well, let's think about it. PacMan uses labels. You can see up at the top high score and the number of points the player has earned. Those are all examples of labels. The ghosts in PacMan are examples of animated sprites. And importantly, those animated sprites have properties. They have a color property. Some of the ghosts are red, some of them are pink, orange, or blue. Also, the ghosts in PacMan have different names. So there's a name property. One of the ghosts is called Blinky. Another one is called Inky. Another one is called Pinky. All of that is stored in the name property. The pellets of PacMan, the pellets that PacMan eats, are all children of a parent. And we could imagine the parent might be called something like Maze. And importantly, those pellets, of course, can be added or removed from that parent. Initially, when the game launches, all of those pellets are added as children. But as PacMan eats them, they get removed from the parent. In addition, all of those pellets have unique X and Y positions. Another way we can connect to PacMan is to think about user input. And of course, when the user is moving the joystick or controlling PacMan with the keyboard, that is user input. And PacMan has to be programmed in order to handle or respond to that input. And all of that is done using functions. So when the user presses left to make PacMan turn left, in order for the program or the game to respond, a programmer had to program that functionality in a function. And finally, we need variables to keep track of important information, such as the player's score, as well as the number of lives remaining in the game. And so I just wanted to help make the connection between what we're learning in Godot and how this might apply to a real-world game such as PacMan. Okay, everyone, we're out of time for today. Have a great week, and I'll see you in Canvas.